Welcome. Have you ever felt like physicists are speaking some kind of secret code when they're trying to explain the universe? Well, today we're cracking open that code. We're going to give you the keys to their toolkit, the essential math that turns those impossible-looking problems into puzzles you can actually solve.
You know that feeling, right? You're staring at a physics problem, you totally get the concept, but when it comes to the math, you're just stuck. It happens to everyone. It's a super common roadblock. But what if I told you the answer isn't to try harder, but to work smarter?
And that's the big idea for today. We're not just going to memorize equations. We are building a toolkit. Think of each math concept as a special key, perfectly designed to unlock a specific type of physics lock. And today, we're adding 3 absolutely essential keys to your keychain.
So let's get down to business and start filling up our toolbox. We're going to start with 3 tools that are, foundational, but also incredibly powerful. You're going to see these things pop up over and over again.
So, what's on the agenda? First up, we've got the vector, which is perfect for anything that has a direction. Then, the infinite sum for tackling problems that seem to go on forever. And finally, the binomial approximation, a seriously powerful shortcut. Let's get into it. Okay, let's kick things off with our first tool, and honestly, this might be the most fundamental one of them all, the vector. If you want to describe pretty much anything that moves or has a force on it in the real world, well, you've got to understand vectors.
So, what is it? A vector is just a piece of information that has 2 parts. The first is its magnitude, which is just a fancy word for its size. And the second is its direction. So it's not just how fast, it's how fast and which way.
And this slide lays out the difference perfectly. On one side, you have a scalar. That's just a number. Like saying your car is going 100 kilometers per hour. But a vector, that's velocity. That's 100 kilometers per hour north. That little which way part is everything.
Now, because vectors have direction, you can't just add them like regular numbers. One of the easiest ways to visualize it is with the triangle law. You just line them up, one after the other, tip to tail, and the final result, what we call the resultant vector, is just a straight line from where you started to where you ended. Simple.
So, why do we care? Well, anytime you're dealing with motion in 2 dimensions, think about the arc of a baseball as it flies through the air, or 2 people pushing on a box from different sides, you are living in the world of vectors. It is absolutely crucial.
All right, let's grab our second tool. And this one feels a little like a magic trick, I'm not going to lie. It's for those times in physics where something seems to happen over and over again, forever, and you need to find the total. We're talking about the idea of summing an infinite series, specifically something called a geometric progression. Now, don't let the name scare you. It's just a list of numbers where you multiply by the same fraction each time, like 1, then a half, then a quarter, then an eighth, and on and on. It sounds kind of impossible to add up an infinite number of things, right? But with the right tool, you get a single, clean answer.
And here it is, the magic formula. The sum is just the first term, a, divided by 1 minus that common ratio, r. Now there is one rule. This only works if r is a fraction between -1 and 1. Why? Because that means each new number you add is smaller than the last. So you're adding tinier and tinier pieces, and the total eventually settles on one final number. It's just so elegant.
And look, this isn't just some weird math thing. If you're studying for an exam like the NEET, this is a must-know. It shows up in questions about electricity, with lines of charges, or in optics problems with lots of reflections. Knowing this little formula is your key to getting those questions right.
Okay, time for our final tool. And this one is a real favorite among physicists. It's a clever shortcut for when calculations get really, really messy. You just have to know the right time to use it.
And this is the golden rule. The only time this tool works is when you're dealing with a number x that is tiny, like really tiny compared to the number 1. We're talking 0.001 or something. And the reason is, when you square a tiny number, it gets ridiculously smaller. So small, in fact, that you can pretty much just ignore it. And that's where the shortcut comes in.
And here it is, the binomial approximation. Just look at how clean this is. That complicated thing on the left, which would be a nightmare to calculate, just becomes that super simple expression on the right. It basically turns a nasty power into simple multiplication. It's a lifesaver. So where do you actually use this? A classic example is with gravity. If you want to calculate how gravity changes just a little bit above the Earth's surface, this approximation's your best friend. But, and this is important, it's an approximation. It's brilliant for small heights.
But if you try to use it for a satellite way out in space, your answer is going to be totally wrong. Knowing your tool's limits is half the battle.
Okay, let's take a step back. We've just collected our 3 essential tools: the vector, the infinite sum, and the approximation. So let's lay everything out and see the awesome kit we've just built.
And there it is, your starter toolkit. You've got the vector for handling motion. You have the infinite sum for those tricky series problems. And you've got the approximation for simplifying gravity calculations. See? Each tool has a clear job.
And that's really the whole point. The math and physics isn't there to stop you. It's not a wall. It's a set of specialized tools. And once you know which tool to grab for which job, even the scariest looking problems start to seem, well, totally manageable.
So now, you've got a toolkit that's a lot more powerful than it was just a few minutes ago. The only question left is, what are you going to build with it? What problems are you going to solve? The universe is out there waiting. Thanks for tuning in.